In this video, we're going to be casting our spotlight on the Dirichlet distribution, which is a generalization of the beta distribution that we saw before. So the beta distribution was useful when we had two options. The Dirichlet distribution is useful for when there are more than two options, and you have a set of parameters, alpha 1 up to alpha k. You might put them in a vector that you just call alpha. And the way that you would use it is that if you had k different categories, for example, transitions out of a state in a Markov model, and you observed actual counts of those different categories, transitions x1 up to xk, then you can use a Dirichlet distribution where alpha 1 is equal to x1 plus c, so on and so on, up to alpha k being xk plus c. And c would typically be 0 or a half. As I said before, I would typically use a half for that. And it's important to note that this is not going to give you a single number, because it's going to give you a set of probabilities, so they will sum up to 1, and then you can use them elsewhere. So because you have more than one outcome, so more than one probability gets produced from this distribution, it's a vector valued distribution. We're going to take up more than one row in this current example. So I've spread my alpha values across 3 different rows in Excel, and then I'm going to take the total of those and store that. The deterministic value of these probabilities is just going to be 5 divided by the total. The total here is 16, so 5 divided by 16 is going to go there, 8 divided by 16 there, 3 divided by 16 there. When we come to the probabilistic values, we're going to do some intermediate calculations. And this is one way of doing it. Another way that you can do it is you can have 2 beta distributions here. So you can have one beta distribution which has an alpha of 5 and a beta of 11, because you're combining those two into a single category. And then you have another beta distribution that has an alpha of 8 and a beta of 3, and you can combine the results of those to get a Dirichlet distribution. Or what is probably a bit more of an elegant solution is for each of those alphas you generate a random gamma distributed variable that has shape alpha and rate and scale both equal to 1, and then you're going to take the sum over those. So just like we had the sum over alphas here, we're going to have the sum over those gamma random variables. And then our probabilistic calculation looks exactly like our deterministic, except we're referring to the gamma variates rather than the alphas. So it's this divided by this, and this one here is going to be that divided by that, and so on. In R, you'll have to use a package called gtools, and it's the R Dirichlet function. Here I've got gtools : R Dirichlet. That means that you can call this function without loading gtools as a full library into your search path. But if you prefer to, you can have, one line is library gtools, and then the next line you don't need that gtools : you just have R Dirichlet. 5 is the number of random vectors you want to draw, and then you give it the alphas that you want. You'll see here that what it returns to you is a matrix, or it's a 2D array where it has 5 rows because you asked for 5 random variables, and it's got 3 columns because it's a length 3 vector that this Dirichlet distribution is producing. Enjoy!